Okay, this is the lecture video for MAC1114 trigonometry. We're in section 6.4 where we will be looking at the graphs of periodic functions, specifically the sine and the cosine functions in this particular section. Periodic functions, as we've been discussing throughout this chapter, are functions that have a repetitive nature in the values that occur for that function. And we're going to be relying on those patterns in order to graph these graphs by hand without creating an XY table. So the first thing that we want to look at is where you can find the various values that will signify or help us to create key points on the graph. Okay, so first I want you to get used to writing your trig function like this, where you have the trig function with the coefficient out in front of it. This will come after the trig function and the vertical shift at the end. So in case they don't give it to you in this order, please rewrite it so that the trig function is the first term. Coefficient will be the A value. The A value is what is used to find the amplitude. The amplitude is actually how high the waves that are signature for sine and cosine graphs. Those waves will go to a certain max and a certain min, and that will be determined by the amplitude, how high and how low the graph goes, also known as max and min, which also gives us the range, because you will be asked to do the domain and range after each graph that you create. So that amp will help you to get that. Okay, there's also what we call the period, and that requires that you know how to find the B value. The B value, as I have shown right here in this equation, comes right after the trig function, but right before the expression containing x. A number that is not part of this x expression, but will determine whether the graph moves up or down, is called the vertical shift. Okay, now when you're finding the period, first here's what a period is. It's the distance it takes to graph 4 points and return back to the original height as the starting point, and I will point that out visually as we get involved with the graphs, following a specific pattern. So every one of these graphs is going to have a 4-point pattern. And those the distance that it takes to graph those 4 points suggested by the pattern, that's called the period. The 4 points will follow the same pattern over and over again, from negative infinity to positive infinity. So I'm already telling you that when you go to do domain for all of these graphs, because you're only concentrating on sine and cosine, the domain of all the sine and cosine graphs will be positive infinity to negative infinity to positive infinity. They just go on and on in the left-hand direction as well as the right. The range, on the other hand, will be determined by the amp. So we're going to consider the amp very heavily when we figure out what the range is. Okay, so I also want you to understand that you have been taught properties in previous sections in 6.2 and also in 6.3, and those concern the even-odd properties, and they will be used quite a bit in the problems that you're going to be doing right now, because you have to understand that if a function is even, and this is again something that came up in section 6.2 as well as 6.3. That if a function is even, and I have restated those properties all over again for you in this section, that if you have even functions such as cosine or secant, these are the only two even functions, the ones that you see right here in the middle, then if there is a negative in the argument, that'll be the expression typically containing x. If there's a negative in there, you can just disregard it. That is only true for even functions. This is the same as this when it's an even function. So you can basically rewrite it without the negative and then go about your business of graphing. However, if you have odd functions, such as sine or cosecant, or tan or cotan, then that negative doesn't just disappear. It floats out to the front and becomes the coefficient of the trig function. And anytime that happens, it's going to cause the graph to flip over, or what we call reflect, about the x-axis. That means flipping over the x-axis. So we're going to very much be talking about that as we do problems where that is brought into the scenario. Okay, the jump, this is a name that plenty of books, I don't know that your book uses it per se, because your book, I think, does these graphs and builds a big XY table, and we're going to just be relying on patterns. So the jump is how you label the grid marks, or the scale as we call it, along your x-axis. Whereas the amp is going to help us to design the scale on the y-axis, and I'm going to show you all of that. So the jump is there's a specific formula for it. It is the period, whatever you get for the period, divided by 4. Each one of these things, you're either just looking for it in a certain location, or you're using a formula. Like when you're going to do the period, you'll keep seeing us have to do the period when we start these problems, because you can't find the jump to label your x-axis without finding the period. And the period for sine and cosine, and again, this part of this is taken from previous sections. The period on a parent graph for sine or cosine is 2 pi, but it is altered by whatever the b value is, and I'm showing you where you can find the b value. Right after the trig function, but right before the x expression. Once you have that period, then yes, you can find the jump. And the jump will just be whatever that period is, cut into 4 parts, since you need to plot 4 points within your period. So this will help us design our x-axis, the grid marks on the x-axis. The expression containing x, it'll be in parentheses. If there is anything either subtracted or added from x, we call this the phase shift. In other courses that you have taken, the phase shift was referred to as the horizontal shift. It means the same thing here. It is just called a phase shift. Remember that horizontal shifts always behave the opposite of what they appear to be doing in the parentheses. So if you see x minus pi, it would really be a phase shift of positive pi. If you see x minus pi, something like this, in the expression that you're working with, let's say there's some trig word in front of it, and then right after it there's the expression containing x, and it says x minus pi, well, that implies that your phase shift is positive pi. Anything attached to the x, you'll switch the sign, and you did that when you were in your algebra classes. You would always switch the sign on the horizontal shift, and we just have a new name for horizontal shift, and that is phase shift. So just a little reminder of that. However, since I'm teaching you to graph these graphs by using patterns, the pattern is going to absorb all the things that need to happen inside the graph, such as a vertical shift, such as the vertical shifts, the phase shifts. Everything will get wrapped right into the pattern technique that I'm going to be teaching you. Starting point, we're going to figure out what makes the argument, that'll be the expression right after the trig word, such as this, cosine of x minus pi. That would be your argument right there. You're going to want to know what makes that 0. And a lot of times you'll be able to tell just by observation what makes the argument 0, because it helps us to figure out the starting point. And I'll be demonstrating that each time I begin a graph. Vertical shift, that'll just be the number on the end. It will not have any kind of a variable attached to it, and you do not ever switch the sign on your vertical shifts, even when you're in your algebra class. Same rules follow into this class. If it's a positive 2, the graph's going to shift up 2. If it's a negative 2, it'll shift down 2. But again, all of those shifts and transformations are going to be absorbed right by the technique that incorporated right into the technique that I'm going to be teaching you, where we will be graphing by patterns. Okay, so before we start doing the graphs, let's just get into some preliminary questions where they're just seeing if you are observing and understanding the formulas that you've been given and some of the things that have been mentioned that are going to lead you up to the skills having to do with graphing. So this was the sine graph. This is a parent sine graph. The difference between this one and the cosine graph is here the starting point's at 0, 0. And here it's up at 0, 1. So whenever you do the graphs inside the software that you're going to be using, and you may be using MyMathLab, you might be using MyOpenMath, you have to get familiar with the tools that are being offered to produce the graph. So I'll talk a little bit about MyMathLab as I do the graphs. Okay, so this is just the parent graph for sine of x, and this is the parent graph for cosine of x. And again, this was just brought up, and we reviewed all the key features of either of these graphs in section 6.3. So I just printed them here for you again. You're going to be producing your own graphs. Okay, here we go. Example 1 now. Like the way the software is that you're using, if you're using MyLab Math, because these videos are used for other classes as well, because the topics are all the same. When you're using MyLab Math, they always start off with questions that just have to do with the formulas and the theorems and so forth. So in this first example, maximum value of y is equal to sine of x. The graph between 0 and 2 pi on the x-axis is 1. That is the highest that graph goes, and that's why I put these graphs for you here again. It goes as high as 1 and as low as -1. This is known as the max, this is the min. Okay, maximum value of y, maximum value is 1, and it occurs at x equal to, and again, you can just look at the graph. So on the sine graph, here's your maximum value of 1, and it occurs at pi over 2. Now let's see what kind of... And with this comment, just in case you get confused here, with this comment, that they want the x to be between 0 and 2 pi, they're telling you to stay on the positive side of the x-axis rather than being over on the negative side of the graph. So when you're looking at this graph, here's this maximum value of 1, and if you're over here between 0 and 2 pi, then the first x value that you hit that's associated with that y value of 1 has to be pi over 2, just so you're not grabbing answers every... Okay, then it says here, for this next one, the function y is equal to -3. That's your a value. I'm going to keep pointing these out so that we're good at finding them when we go to start doing our own graphs. B value comes after the trig function but before the x, so that would be your b value right there. Now this a value gives you the amp, so it has an amp of, remember when you're doing amp, it's just absolute value of whatever the a value is. So if they give you a -3, your amp is 3. So in other words, your amp is always positive, because that's what absolute value does. Period, that has a formula. It's 2 pi divided by b, the b value. So in this case, it would be 2 pi divided by the b value. B value is 6. Your period turns out to be pi over 3. Okay, example 3. Decide whether the following statement is true or false. The graphs of y equal to sine of x and y equal to cosine of x are identical except for one is horizontally shifted with respect to the other, and that is true. We talked about that in section. You can just look at the graphs and see that one is shifted with respect to the other. Example 4, determine whether the following statement is true or false. For y equal to 3 times sine of pi times x. Again, this is called the argument, and that argument contains the b value. This is the a value that helps us get the amp. The amp is 3. That's true because it's just absolute value of whatever the a value is, and of course that is 3. And the period is, well, let's see what the period would be. We have a formula for period. It is always, for sine or cosine, it starts with 2 pi divided by whatever the b value is, and the b value in this case is pi. Okay, it'll be right after the trig function, but right before the x, so wedged in between the trig function and the x expression. So we have 2 pi, our b value is 2, and so our period comes out to be just an integer. It doesn't even have a pi in it anymore. So it is equal to 2, and therefore this statement that the period is pi over 2 is false. Oops. Okay. Decide whether the following statement is true or false. For example 5. The graph of the sine function has infinitely many x-intercepts. That's true, because this graph actually goes on and on in the right direction as well as the left direction. They just go on and on this way, on and on this way. So infinite, it touches the x-axis infinitely many times if you let the graph go on and on. So true. Okay, moving to number 6. Okay, in example number 6, this says one period of the graph y is equal to sine times omega x, and they're just using that symbol there, but that's really the b value is what we typically call it, and the a value would be out here. Or y equal to cosine omega x, or again, that would be the b value, is called another name for period, the distance that it takes to plot all 4 points of the pattern belonging to that specific trig function. It's also called a cycle. To plot the 4 points of the function's pattern. And you're plotting those 4 points. When you first plot the first point, you'll have a particular y value. So you're going from one y value and you're plotting the rest of the points until you return to that same y value. And that is that's another way to just describe what a period is, the distance that you're traveling, which is called a period or a cycle. Okay, and example 7. To graph y is equal to 3 times sine of negative 2x using key points, the equivalent form of this, now here they're trying to see if you understand what the even and the odd properties state. Okay, first of all, you have to know which one this is. The sine function is an odd property. And whenever you have an odd function, that negative doesn't just go away. It only goes away when it's an even function. Once again, the even functions, they are printed for you on the first page, and they are cosine and secant. Cosine and its reciprocal. Those are even functions. Everything else is odd. And when you're dealing with an odd function, what happens to the negative is you always want to rewrite this expression so that there's no negative in it. And that's what the even and odd properties allow you to do. Can't erase it. It floats out front and becomes part of the coefficient. So equivalent form that you'd be working with to plot would be negative now out front, and now your argument is now positive, just being a 2x rather than a negative 2x. So you're going to want to address any negatives that are inside the argument using the even, odd properties. To just decide whether it's an even or an odd function. If it's odd, that negative floats out to the front. If it's even, you can just get rid of it, rewrite it without the negative. Okay, so that answer was, let's see, which one looks like the one we just got? Negative 3, nope. Negative 3 is out here. That would be this choice right here. Okay, moving to example 8. In example 8, they're asking you to determine the amplitude and the period of the following function without graphing. Okay, so the amp is just have to know where to look for it. Has to do with this A value. The period has to do with the B value. So the amp is just absolute value, and you don't have to show work. You do have to know that it is positive, though. So this would just be 4/5. Okay, the A value can be either positive or negative, but the amp is always positive because you're taking the absolute value. Period, on the other hand, has a formula. It's 2 pi, starts off with 2 pi because the parent graphs have a period of 2 pi for sine and cosine. And then it gets altered, in other words, squeezed in or stretched out, the graph, by way of this B value. Okay, in this course, you have to be, on top of your skills with respect to complex fractions because they happen often. So here I have a complex fraction, and the way you simplify is just float the divisor to the top and flip it over, because multiplying by the reciprocal is the same thing as dividing by 5/4. So now this is up here acting as the reciprocal. It will be top times top, 8 pi, divided by 5, and that's your period. Okay, so moving on to example 9. So in example 9, we start doing graphs, and the bulk of this section has to do with you being able to graph. Okay, we're going to be graphing by hand. We're going to lay out all of the things that I put for you on the first page, what the amp is, what the period is, what the jump is, and we're going to use all those things. We're going to find the starting point of the graph. We're going to use those things in conjunction with the pattern for sine and cosine. Let's review those patterns before we get started, because we've already been going over amp and period quite a bit in the examples that just happened. Okay, so let's see, where was this stated? Might be on this page. Okay, so right here are the patterns. Okay, this is the pattern for the sine graph. For sine graph, you're going to be using MUMD. That's middle up, middle down. That's going to be the pattern. The very first letter of the pattern always has to do with your starting point. Your starting point will be at that level, because you're going to see as I lay out these graphs by hand that knowing what level, because there's going to be 3 levels when you set up your graph. There's going to be a middle level, an upper level, and then there's going to be the lowest level called the downward level. Middle, up, and down. And those 3 levels will sort of look like shelves in a bookcase. And you're going to travel to those various levels each time you plot the point. You'll be using the jump and the levels that you put in place that have to do with middle, upper, and downward. And that's how you're going to plot points, rather than creating a big long table and calculating the y partner for each x value. You're not going to be doing it that way. So this is the pattern we'll use. Notice that it is a 4-point pattern. Each time you act out one of these letters, you're going to be plotting a point. The cosine graph, on the other hand, has a pattern called upper, middle, downward, middle. So this one has a different pattern. Every single time I do a problem, I'll restate the pattern just so you can get used to them. Again, whatever the first letter is, that's the level that your start point will be at. Okay, here we go with the graphs. Okay, so first let's lay the groundwork for the equation that we've been given in example 9. Okay, so first thing we're going to do, and try to get an order in which you do things so that you're not scrambling around doing it differently each time. That just causes confusion. Okay, so the A value here is 3. Therefore, the amp is absolute value of 3, just 3. The period is 2 pi divided by the B value. And we'll label things here. This is A, and this number right in here, you see that there is no number right in there, therefore B is 1. The A value you can see right there, so it's just 2 pi divided by 1, or just 2 pi. And you can skip some of these steps if you want. You know, like when the B value is a 1, I don't mind if you just go from this to this. And I don't mind if you just go from this to this without showing that. But I am not going to skip any of the steps because I'm trying to get people who have never seen this before to understand where these numbers are coming from. Okay, next thing is, how do I lay out my x-axis? Well, how do I number the grid marks on my x-axis? That's called the jump, and it is this formula that allows you to get that scale, the jump on your x-axis. It's the period cut into 4 parts so that you can accommodate a 4-point pattern. Okay, my period was 2 pi. I'm dividing it by 4, therefore my jump is, reduce this, pi over 2. I'm going to have grid marks every pi over 2 units. Okay, so I got my jump, I got my period, I got my amp. Let's see, what else? Start point. Start point, I'll just abbreviate it SP, but for right now I'll write it out like this. First you have to go and look at the argument and ask yourself, what would make this 0? Well, this argument is so simplified that you could just tell, just plugging in a 0 right there would make x equal to 0. So when you figure out what the value is that would create a 0 here, then that's what you're going to put as your x coordinate of your start point. All right, then what you're going to do in order to get the y partner is you're going to actually plug that value in, which is always how you get a y partner. You're talking about a particular x value. We're interested in the x value that zeroes this out, and that would be 0. And we want to know what the y partner is once we put this number right in here. So it would be y is equal to, and you can use your calculator for this part. Okay, if I put a 0 in there, this would read y is equal to 3 cosine 0. So you can pop that right into your calculator. 3 times cosine is 0. I'm not going to show it each time, but I will for this one. Your mode could be in degrees or radians because 0 is universal with respect to degrees and radians. So it's just 3 times cosine 0. See? You get 3. That's because cosine at 0 is 1. 1 times 3 is 3. So some of you may be doing that in your head. Otherwise, you can just put it right in here. So when x is 0, y is 3. That's going to be your start point. Okay, the pattern that we're going to be using, well, for cosine, it's And I'm also going to show you what to do to the pattern to make the entire graph flip over. Because you know how sometimes you have a function and there's a negative out front? Having a negative out front in your A value is what makes the graph flip over. So I'll show you what to do to the pattern to make the pattern flip it over. But we don't have that. We don't have a negative yet. We will run into plenty of that. So we're just going to use the basic pattern for cosine, which is up, middle, down, middle. I'm done. Okay, let's transfer this all over to the next page where we're going to begin the graph. Yeah, I'm just going to put some of that information right here. Amp is 3, period was 2 pi, the jump, pi over 2, start point was 0, 3. And the pattern is up, middle, down, middle. Okay, so you just need all of that so you can put it all together to create your graph. Okay, first thing you're going to want to do is plot your start point. And ask yourself, what level am I at? Upper, middle, or downward? So let me show you how this works. This is your pattern. Up, middle, down, middle. That very first letter tells you what level you're at with respect to the start point. So let's go and plot that point. This will be 3. And since that first letter tells us what level the start point is at, make a horizontal shelf right through that point and label it upper. It is the uppermost level on this graph. There will be no points higher than this upper level. Okay, with respect to the other levels, well, those are easy to put in place because the other levels are separated by the amp. So the amp spaces the 3 levels of the graph, upper, middle, and downward. Okay, so what was our amp? 3. That means there's a distance of 3 between the upper, the middle, and the downward. So from upper to middle, just go down 3. This will be your next level right here at the x-axis. This x-axis also plays the role of the middle level because you're going to be reciting that pattern to yourself as you go and graph, and you're going to want to know that that x-axis actually plays the role of the middle level. Okay, then we're going to go and space out 3 more. 1, 2, 3, going down to -3, and that's going to be our downward level. No points will be any lower than this. So when you're graphing these things, you're going to see that the game that I'm going to talk about is so old that probably many of you won't know it, but it's like a Pac-Man game. You'll put the start point and then you'll go down, plot a point, all the way down, plot a point. As soon as you get to the bottom, you can't go down any further. You'll start bouncing back up to the top, always stopping at the middle as you travel from lowest level to uppermost level, but I'm going to demonstrate that. Okay, so we've plotted the start point. That told us what level we were at by just looking at the first letter of the pattern. We knew that 0, 3 was at the uppermost level. We then spaced out the other levels according to the level that we know about, the first one, which is the upper level, by using the amp. So that amp just means that's the spacing between each of the levels. So from here to here, distance of 3. From here to here, distance of 3. Now let's get the rest of the points. The pattern will give us the rest of the points. And that pattern just repeats. Okay, so this was, we already did this point. That 0, 3 was our uppermost point. So now we're ready to move to the middle. But we need to know, how much should I slide over each time? Because every time you plot a point, you need to know how much to move over horizontally and at what height you should be at, your y coordinate. It's just that you're doing it by using these shelves and by using, by using the jump and all of that. So I need to get some numbers on this x-axis right here. So our jump was pi over 2. That means every time you go to plot a new point, and right now I only have one point, you are going to slide pi over 2 units horizontally, either to the right or to the left, because you can plot points over here also. Why don't we get what's over here on the positive side? So I am going to use that pi over 2 for my scale. Like this will be pi over 2. This will be, count in ones, this will be 2 pi over 2. Because if you're going to reduce as you label, the counting will be much harder. So 1 pi over 2, 2 pi over 2, 3 pi over 2. 4 pi over 2, and so on. You could keep going. You could keep going this way, or you can come over here and get yourself some negative numbers. I'm going to do part of the negative side. So that would be negative pi over 2. This would be negative 2 pi over 2. This is negative 3 pi over 2, and this is negative 4 pi over 2. You might want to label every other grid mark just because they just start jamming into each other, because we can only get graph paper that's so big without going nuts here. All right, so here we go. Now we can carry out the rest of the pattern. So now we want to do the point that's at the middle level. And before we can do that, we need to slide over pi over 2 units, drop down to the middle level, plot the next point. Then slide over pi over 2 units again and do what the pattern says. Now it says go to the downward level. So slide over pi over 2 units, drop all the way down to the bottom level. So you're starting to get part of the graph. Okay, now I'm at the downward level, go back up to the middle level. But again, slide over pi over 2 units and then go for the middle level. Slide over pi over 2 units and go to the upper level. So you have the right side of the graph. And you can keep going on this side if you want, or you can go back this way. All right, so if you want to go back this way, look at the pattern, because you really don't even have to look at this anymore. I did it for the first 4 points. I did it for this, 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 and this. And we went upper, middle, down, middle, and then I did like an extra point here. Okay, notice that I always slid over pi over 2 units from each point that I plotted. I was always sliding over pi over 2 units. That gave me 4 points. I ran out of that, and so once you get to the end, but you're going to see you don't need to look at this throughout the whole problem. Once you get to the end, you can come right back to the beginning and repeat those, repeat the pattern again, which is what I did for this point. Or you can just use common sense here. You can just visually follow the pattern. You're always staying wedged in between the uppermost and the lowest level. So if you're at with this point, you want to get some points over here. If you're at a point where you're at as high as you can go, you have to start coming down. You have to start falling down to plot a point. You always have to plot a point on the middle level as you pass from highest level, uppermost level, to downward level. So I'm going to slide over pi over 2 units, drop to that middle level, plot a point. Slide over pi over 2 units, drop to the lowest level. Can't go any lower now, so you have to start your climb upward. Slide over pi over 2 units, go to the middle level before shooting all the way to the top, plot a point. Slide over pi over 2 units all the way to the top. And now you have some more points. Just connect the dots. And you have your first graph that has been altered by the specific conditions in this problem, namely the 3. Because instead of this just being cosine of X graph, it was altered by this amp of 3 that is not part of the parent graph. So all of these will have one or more things that alter the graph with respect to its parent graph. Okay, they're also asking you what is the domain and the range here. Well, I had gone over on previous pages that the domain for all sine and cosine graphs is negative infinity to infinity. It does go on and on if you want to continue it. And the range can just be told by how high and how low does it go. So the range in this particular case, it goes as high as 3 and as low as negative 3. Now you are being asked in MyLab Math or whatever software you're using to use interval notation, which is what this is. And now I'm going to give the interval for the range. The range are your y values. For interval notation, you must say the smaller quantity first, then the bigger quantity. So there's domain and range. With respect to how you're going to feed this into MyLab Math, they have like a little toolbar that you have to answer a few questions. So the first thing that you're going to do for this particular problem is you're going to choose the tool that signifies you're graphing a cosine graph. So you'll have 2 little emblems that look like this. They'll have like a wave on them. And if you hover on each one, it'll light up either the word sine or cosine. So you'll know which one you're picking, even though there's certain things that help you tell that also. But you're going to choose the cosine tool because this was a cosine problem. Okay, and this is when you're in MyLab Math, just to get that graph to come out right. Okay, first you choose the tool. Next thing you're going to do is click on a point that's on the graph. And since we've already bothered to figure out what the start point is, you might as well use that one. So you can just click right on 0, 3, and your graph will highlight that you're actually clicking on those numbers, so you won't be guessing at them. You'll see the numbers you're clicking on. Then the next thing that it's going to ask you is to provide the amp. And the amp here was 3. It's also on that same line going to ask you to provide the period. And the period in this case was 2 pi. And then they'll have 2 boxes down at the bottom. One says reflection about the x-axis. And you only check that off if the graph is flipping over the x-axis. Okay, so let me write a little comment about that. This is not a graph that flipped over the x-axis. It did not have a negative out in front. And once again, let's look at this so you can tell. You're going to look at this a value, and if this a value is negative, that's when you're going to have a negative right out here, which causes the whole graph to flip over the x-axis. They use the word about. Flip reflect about the x-axis. That's the mathematical terminology. So I'll make this comment right here. You're only going to check reflection about the x-axis if your A value is negative. Okay, only check that box off if your A value is negative, because that means your graph is going to be flipping over. Okay, so let's go to number 10. Now as we go along, things will get more and more involved, and I'll take you all the way to the harder problems. So graph this particular function now. Okay, so the next one we have is y is equal to -4 sine of x. Okay, so just to conserve room here, this is y, this is x. I'm going to do some of my work here. My amp is absolute. Now notice that you have an A value that's negative here. The amp is always positive. It is 4. My period for this is 2 pi divided by, okay, look right after the trigger but before the x. There's nothing but a 1 there, so it's just 2 pi. See, what else can we do? We can do the jump. In other words, how to lay out the x-axis. And that is this formula. It's the period divided up into 4 parts. So we're going to do 2 pi divided by 4. That's going to give us pi over 2. That will be our jump. This is our period. That we'll tell the software that we're using. And this is our amp. Okay, start point. The start point, let's go over that. You ask yourself, what has to be plugged in right here into the argument to make it 0? And that x value would be 0. Then, in order to get the y partner, you go and use your calculator. You press into your calculator y is equal to, and you're not going to even press in the y is equal to. You just want to press in this portion right here, -4 times sine, and we're plugging in a 0 there in order to zero out that argument. So you're just going to press this into your calculator, and when you do press it into your calculator, I'll press in a couple of them for you, but then I'm just going to say them verbally. When you do sine of 0, you get a 0. And so when you multiply -4 by it, you're still going to get a 0. See? You can let your calculator do that part of the calculation. Okay, so that's going to be our start point. And then our pattern, now watch what happens here with the pattern. When you have a negative A value, the whole graph flips over. So what makes that happen is you taking the pattern that typically would be the pattern, which is for sine is middle up, middle down, and to make it flip over, you're going to switch up to down and down to up. That way it'll reverse the direction and make it flip right over the x-axis. But everything else will be based on these values that we've just discovered. So make sure that when you go to graph, you are paying attention to this pattern. I mean, I suggest you write the typical one and then look at it and switch it as you're doing it. You can do it in your head if you want to, but more chances for mistakes. So that's the pattern that we are going to be using in order to make the graph reflect over the x-axis. Okay, so here we go. All right, so we're going to do that start point. That start point was 0, 0, and we're going to establish what level we're on. Okay, remember that the first level, the first letter of the pattern tells you where the start point is. So that means this is at the middle level. So that middle level is right there. And by knowing just where one of the levels is, it doesn't matter which level you know about. As soon as you know where one of them is, you can put the other ones in place by way of the amp. So the amp here is 4. So we're going to just go up, 2, 3, 4, and we're going to put in what would be above the middle level, the uppermost level. We'll put our uppermost level right in there. We can label it. And then we'll also put our downward level. And do the same thing. Just like you amped 4 units to go up, go down 4. 1, 2, 3, 4. And this will be our absolute lowest level on the graph. Okay, so as we plot our points, we're just going to be heading for these various levels based on the pattern that we're using. Now we've already taken care of the 0, 0 at the middle level, so now we're going to go from there. We need to know how far to move over each time. Therefore, we need some numbers on this x-axis. I cannot grade your graph without things being numbered. All right, so let's see. What is our jump? Our jump is pi over 2, and that jump helps us design the x-axis. So this will be, and again, you might not want to label every single grid mark. This will be 2 pi over 2 because they jam into each other. 3 pi over 2, and then this would be 4 pi over 2. Likewise over here, this will be negative pi over 2, 2 pi over 2, 3 pi over 2. Because you're being asked to give at least 2 cycles. So this is a cycle over here, and this is a cycle over here. So, I'm going to move this in so I'm sticking all the way out here. Okay, so this is my middle level. All right, so make sure you're paying attention to this now, not the original pattern. So we're going to go, typically we would go up, but since we're flipping over, we have to go down instead. And that reversal of direction based on you switching the U's and the D's is what makes it flip over. Okay, so slide over pi over 2, go for the downward level and plot that point. Slide over pi over 2, go for the middle level to plot your point. Slide over pi over 2 and do what the last letter says. Go all the way to the upper level. And you can keep going if you want. And you're going to see what's happening here. I mean, of course, if you're at the highest level, you'd start coming down. So if you do want to do more, you can just say, okay, I'm going to slide over pi over 2, go to the next closest level, slide over pi over 2, continue going down, and then you could start your ascent back up. You can make as much of this graph as you want. It does go on to positive infinity as well as negative infinity. Just to get some points over here on the negative side, I'm going to slide over pi over 2. I was on my way back up. I just hadn't gotten all the way to the top. So slide over pi over 2 all the way to the top. Now that you're at the top, if you want to keep plotting points, you have to start coming down. So go over pi over 2 and go to that next level. Go over pi over 2 and all the way down. Once you get all the way down to the bottom, you have no choice but to start going up. So if you want to plot points, you could slide over, go up to the middle, slide over, all the way to the top. Do as much of it as you want. All right, so that's our graph there. With respect to domain and range, this is the domain. Negative infinity to infinity. This is the range. Look at how high and how low it goes. You're giving these an interval notation. It goes as high as 4 and as low as -4. And it actually has points right on those numbers. Okay, that's also known as your max and your min. Okay, as far as what you'd be feeding into the calculator here, well, first you would choose the sine tool. This is a sine function. That's just the shorthand way of writing sine, S-I-N, rather than S-I-N-E. So choose the sine tool. Then you would click on any point that's on a graph. But we already know a specific point on the graph, and that point is the start point. Any point that's on the graph would have been good. So we can just use something that we've already found. And then let's see, what else? After that, it's going to ask you for the amp. So provide that amp. And the amp in this case was 4. It's going to ask you to provide the period. And the period here was pi over 2. And then it's going to ask you to check off whether there's a reflection across the x-axis. It also asks, is there a reflection across a y-axis? And there's no problems like that are being given. So you are going to check off reflection. And that's because you have a negative a value. Look at that negative a value right there. Reflect about the x-axis. Just check off that box and it'll know to flip the graph over. Now we've already flipped the graph over by using this reversal of ups and downs in our pattern. So this graph is already flipped over, but if you want to make MyLab Math do that, then you have to answer these questions. Okay, let's go to number 11. Number 11 has another reflection. Again, notice that the a value here is negative. You are going to reflect over the x-axis. Okay, and let's go through all the things that we have to do to get it by hand, as well as in MyLab Math. Okay, so let's see. Amp here would be absolute value of -1, because that's your a value right there, which is 1. Amp is only going to be 1. The period is going to be 2 pi. Both sine and cosine start with 2 pi divided by the b value. Well, this is your b value right here. So we're going to divide by 6. This time we have a period of pi over 3. Well, that period is used to get the jump, which helps us lay out the x-axis. So the jump is the period divided by 4. So when you divide by 4, that's the same thing as multiplying by 1/4. Just flip that number to the top and write it as a reciprocal. So that is pi over 12. Okay, that's your jump. This is your period. This is your amp. Next is the start point. The start point, ask yourself, what could you plug right in there that would create a 0 in the argument, and that value is x equal to 0. So 0 is our x coordinate at the start point, and then if you want the y partner, well, this says you want y, it's equal to negative sine of 6 times whatever you're plugging in for x. So that would just be negative sine of 0. 6 times 0 is 0. Okay, when you plug this in, you get a 0. 0 times -1 is 0. So you have a y partner of 0. So that's our start point. Okay, the start point in conjunction with the pattern will tell you what level you're at. So the pattern, okay, let's be careful here because we do have to switch it. This is the old pattern before we start reflecting. And I'll put the new one down here. The old pattern for sine is middle up, middle down, mum-D. But if we're going to start switching the ups and the downs, because you can't switch middle. Middle is middle. But if we reverse the up to a down and we reverse the down to an up, that will flip it over the x-axis. So this is the new pattern that we're going to be using. Middle down, middle up. So as I said, the start point in conjunction with the first letter of the pattern tells you where this start point is at. The start point has to be at the middle level because the first letter of the pattern is M for middle. Okay, so that's where we start our graph off at 0, 0. We know that we're at the middle level. And if we want to put the other shelves in place, we just simply use the amp. So the amp is 1. I'm going to use 2 grid marks just so it's not so scrunched together. I'm going to let this represent 1 to stretch it out a bit. And this would be our upper level because upper level is always right above the middle level. And this is going to be our middle level right here at the x-axis. And then I'm going to let this be -1. Label those axes so I know what you're doing. So I can grade the points on your graph. And this will be the downward level. Alright, so just so they're real obvious, I'm going to put them in colors. And this is my lowest level down here. I already have one of my points plotted, the start point, and now I'm going to look to the rest of my pattern, that revised pattern, and I'm going to continue with it. So now it says next point is at the downward level. So typically a sine graph would go from middle up, but if you're going middle down, it forces it to flip over. So let's see, I need some numbers right along here. My jump is pi over 12. That means I'll let each grid mark, this is the easiest way to do it. Just design your own scale down here. This is 1 12, 2 12s, 3 12s, 4 12s, 5 12s. And then you can number the same way here. This would be -1 12, 2 12s, 3 12s, 4 12s, 5 12s. Then on the negative side. And then you can go ahead and continue plotting now that you know how far to move to the right or left, and then the levels will give you how high or how low to go. So we have that 1 point. Slide over pi over 12, do what the pattern says. It says next point after that start point should be a downward point. So at the downward level. Slide over pi over 12, do what the next letter says, that you should be at the middle level. Slide over pi over 12 and give yourself a point at the upper level. And you can connect these points as you go along. You can even make some more if you want. Next thing would be to start coming down. So now you're going to slide over pi over 12, drop to that middle level. Slide over pi over 12 all the way down if you want to give yourself a couple more points. And you can get some over here. You don't have to look at the pattern anymore. You were at the bottom, then you were at the middle, you're on your way up to the top. But slide over, because all of these points are spaced out by a value of pi over 12. So over pi over 12 and all the way up to the top. Over pi over 12, start to come down again. Over pi over 12, all the way down. Over pi over 12, start coming back up. Over pi over 12, all the way up. to give yourself a few more points. Okay, there you go. All right. Here's sine of 6x. Okay, so let's see. What would the domain and the range be here? Domain is same for all of them, negative infinity to infinity. They're going to ask you that in MATLAB math. The range, very easy to see by the graph. It goes as high as 1 and as low as -1. Whoops, got symbols here. Use brackets to signify that these points actually are part of the graph and therefore part of the range. And then commands that you would be putting in MATLAB math, just so you're not going nutty there. You're going to choose the sine tool, because this is a problem concerning sines. Then you're going to provide the amp. Oh, you got to click on a point first. Before that table will open up that asks you for the amp and the period, you have to click on a point, and I just have suggested that you use your start point, which in this case was 0, 0. Then you could provide the amp. It'll ask you for that first. And this amp was 1. You provide the, the period. And the period here turned out to be pi over 3. And then when it says reflect, yes, you're reflecting because that a value is negative. So you're going to check off reflection about the x-axis. I'm not going to write out every little word. Okay, so I think you kind of get the idea. If we get to a problem that's significantly, if there's something new to put here in the commands that you would be telling MATLAB math, then I will state that. But I think for this one it is different, because now all of a sudden we actually have a vertical shift. So you're going to have to tell it when you have a vertical shift. That'll be one of the questions that it asks. And I believe for that it's just like a dial that you slide to whatever number is the vertical shift. Okay, so in this one, number 12, let's see, let's do the amp. Amp is equal to 4. It's just the absolute value of that number right there. The period is 2 pi divided by whatever your b value is. So know where to look. This is where the b value would have been. There's nothing there, therefore it is just a 1. Your a value does not cause any sort of a reflection, because all it is a positive 4. Okay, so your period is just 2 pi. Your amp is 4. Your jump is based on your period. It's the period divided up into 4 parts, so you can use it for the 4-point pattern. So your period was 2 pi, divide by 4. You end up with a jump of pi over 2. We'll use that for our x-axis. And then our start point, what would zero out that argument right there where the x is? 0. You want to know what is the number that when plugged in there would zero it out. It has just happened to have been 0 for each one that we've done. So 0 there. And then what would you get if you actually, for this entire function right here, if you plugged in a 0, then it would be, you'd have y is equal to, once you put the 0 in there, 4 times cosine of 0 plus 1. And if you feed this into your calculator, it would do cosine of 0 is 1 times 4 is 4, 4 plus 1, 5. And you don't have to be able to do that in your head. You can just, like I said, put it in your calculator. Just this part. Okay, so our start point is going to be at 0, 5, and we are simultaneously going to work that start point with the pattern. The pattern in this particular case, we're doing a cosine graph, no reflection. So it's just up, middle, down, middle. And if the very first letter of this pattern says U for up, that means that this start point right here is in the uppermost position. So by knowing what level that point is at that we plot to begin the graph, 1, 2, 3, 4, 5, we also know where the other levels are. Okay, this is as high as that graph goes, also known as the upper level. And then we're going to space out the rest of the levels based on the amp. So the amp was 4, so drop down 4. 1, 2, 3, 4. And this would be your middle level. Usually your middle level is at the x-axis, but do you see how this particular function has a vertical shift of 1? Well, by picking up the middle level from the x-axis up 1 unit, the entire graph shifts 1 unit up. So as I stated before we started graphing, the patterns are going to incorporate all the changes in the graph that shifts it around. So you have your middle level here. You don't have to worry about it carrying those out, by building a table. And then if we go 4 units down, so there's a spacing of 4 units from upper to middle, and likewise from middle to downward. So 1, 2, 3, 4. Okay. All right, so our start point is there. We'll look at the rest of these letters, and then we can kind of not even have to look at the pattern if we want to build out more of the graph. Okay, so here we go. We need some spacing on this x-axis. Got to get some numbers on there, and I believe the jump was pi over 2, so we can call this 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. If you just kind of label every other one, it's very apparent what the scale is, and you won't have everything jamming into each other as much. 2 pi over 2, negative 3 pi over 2, and so forth. 4 pi over 2, 5 pi over 2. We already have numbers on the y-axis, so here we go. So slide over pi over 2. Pattern says as our second point that we should drop to the middle level, which makes sense because you have to start coming down and you can't skip over the middle level. So this would be the next place to plot a point. Go over pi over 2 all the way down. Can't go any lower than this, so you have to start coming up. Slide over pi over 2. Don't skip over that middle level. Always plot a point as you pass from lowest level to upper level. If you want, you can connect some of them right now or connect them all at the end. Okay, so I'm going to do a few more here. Slide over pi over 2. I was on my way up, but I haven't hit the top level yet, so slide over pi over 2. There's a point. Slide over pi over 2. Begin to drop down. Slide over pi over 2 all the way down. And I think I'm going to stop right there. And then I'm going to get some points over on the other side, which is slide over pi over 2, begin to come down, slide over pi over 2 all the way down, slide over pi over 2. I'm going to start to come up now because I'm all the way at the bottom with this point. But I'm going to slide over pi over 2. Make sure to plot a point at that middle level before going all the way to the top. Slide over pi over 2 all the way at the top. Slide over pi over 2, start to come down. And maybe I'll stop there. Okay, there's the graph. Domain. You can also get any point you want off of this graph. Like if I was to ask you, is pi over 2 comma 2 on the graph? I could ask you a question like that. No, it is not. What this graph says, this gives you exact points that are on the graph that you may not be able to tell if you're looking at a calculator. So if you're looking at this, what this point is with pi over 2 is it's pi over 2 and the y coordinate is 1. So no, that is not on the graph. But you could be asked questions like that about specific points on the graph. So anyway, I had given the domain as far as what the range is. Let's see. It goes as high as 5 and as low as 1. It's -1. That's -2. And this is -3. So it goes as high as 5 and as low as -3. Okay, so when we do the range, give it in brackets. Smaller number first, higher number last. If you were going to feed this into MyLab Math, you would choose the cosine tool, because it's the cosine graph. And you would click on a point. Click on a point that you know is on the graph, which we already know that 0, 5, our start point, which is what kicked off the whole graph. Let's see, then you'd be asked, what's the amp? Amp is 4, that would be one of the questions. You'd be asked, what's the period? You'd have to answer that, which was just 2 pi. You'd be asked, there's a dial for vertical or phase shift. Now, there's no phase shift because if there was a phase shift, it would be right in here, a number either added or subtracted to the x expression. I don't know if there's any problems even like that in there, but your vertical shift, you could just slide the dial over to +1 and tell it that yes, and it will, as you feed this information in, it's going to keep adjusting it as you feed in each new piece of information, like clicking on the start point, giving it the amp, the period, and then finally it will finalize the graph once you tell it what the vertical shift is. Okay, going to example 13. In example 13, it says graph the function of -5 times cosine of pi over 3 minus 2. Okay, so, and I think what I'm going to do for this particular section, hold on for 1 second. Oh, maybe I'll just finish it now because I don't have that many more problems. Okay, so the amp is absolute value of that negative value. This is your A value. Keep in mind that you are looking at a negative A value, and therefore you are going to reflect over the x-axis. I've got to keep that in mind because we have to remember to switch our pattern so that it makes it flip over. Okay, so our amp is going to be 5. Our period is going to be 2 pi, just use the formula, divided by the B value. So that would be 2 pi, the B value, know where to find it. It comes after the trig word, but before the x. It'll be wedged in between the trig word and the x expression. So pi over 3 is our B value. Okay, you got a complex fraction here, which you can simplify by floating this divisor up to the top, flipping it over, and using it as a multiplier. Okay, dividing is the same thing as multiplying by the reciprocal. So the reciprocal is 3 over pi. The pi's cancel. You have one in the numerator, one in the denominator, and all that you're left with is 2 times 3. So that 6 represents the period. Your jump is just going to be the period divided up into 4 parts. So your jump this time is not going to have a pi value in it because your period doesn't have a pi value in it. This divided by this ends up being 3 over 2. You could think of that as 1.5 if you'd like, or you could just count in, you could go 3 halves, 6 halves, 9 halves. You could count in fractions. All right, so let's see. Let's get everything going here. Start point, we didn't do that yet. What would zero this out, this entire expression right here, if you put a 0 in for x? So 0 will be your x coordinate, and then the y coordinate, as I keep showing you, is you finding the value of this expression on the right side once you've plugged in this for x. So it'd be -5 cosine of pi over 3. We're putting in a 0 right there where the x was, -2. So what you're really feeding into the calculator is -5 cosine. You're purposely choosing a value that when plugged in for x will zero this out. So you're always going to end up feeding into your calculator either sine or cosine of 0. So this times this, that would be cosine of 0 -2. So that value, when you put it in your calculator, is -7. That's because cosine at 0 is 1. 1 times -5 is -5. Take away yet another 2, -7. So that is the y partner on your starting point. Okay, then using that start point with, let me just bring it down here, with your pattern, and the pattern for cosine, well, typically the old pattern would have been UMDM, just like that. But you want to make this pattern, you want to force the pattern to flip over the graph. So you switch the U's to D's. Can't switch middle. And the D's to U. And you have a new pattern, DMUM. That's the pattern that you're going to create this flipped over graph with. Okay, and I keep trying to bring to your attention that the first letter tells you where this start point is. Tells you what level the start point is at. So we are at the lowest level, the most downward level when we plot the 0 and -7. This will be 1, 2, 3, 4, 5, 6, 7. This will be -7 right here. And I'm going to go ahead and show that that level right there is the downward level. Okay, that's the downward level. And then spacing between any of the two levels is just controlled by the amp. The amp is 5, so let's amp up 5. 1, 2, 3, 4, 5, and that will be my middle level. And then we're going to amp up 5 again. 1, 2, 3, 4, 5. And at the same time, you're helping yourself figure out what the range for this graph is going to be. So there's your middle level, and then your upper level is this one. Okay, so we already have this start point. That was at the most downward level. Now we're going to go to the middle level and plot a point, then the upper level and plot a point, and then the middle level. But we need to know how far to slide over. So we need to use this jump right here to label the grid marks on the x-axis. So if you're not comfortable counting in fractions, you could go 1.5, then another 1.5, and another 1.5. I'm just going to keep it like this. So this will be 3 halves, 6 halves. Don't reduce as you go along. It'll make it too hard to count. 9 halves. So each time the numerator is jumping in increments of 3. 3 halves, 6 halves, 9 halves, 12 halves, 15 halves, and so forth. Likewise over here. Negative 3 halves, negative 6 halves, negative 9 halves. I'm just squeezing all of them in there so you could have practice counting in fractions. Anyway, that's what each of your grid marks stands for. So now when I go to plot the rest of the points beyond my start point, I know how much to slide over because I've already labeled it here. So I'm going to move over 3 halves. Each time you're moving over 3 halves. And I'm going to plot my next point, and this pattern says that my next point should be plotted at the middle level, which makes sense because you're as low as you can get and you have to move up now. Start moving up. You always have to plot at the middle level before going to the upper level. So slide over 3 halves, plot at the middle level. Slide over 3 halves, go all the way to the top now. Slide over 3 halves, start to come down now. Slide over 3 halves, down, back down to the middle. Slide over 3 halves, all the way down. If you're at the lowest level, you have to start going up. Slide over 3 halves, back up to the middle. Slide over 3 halves, all the way to the top. Now connect. Okay, this was your start point right here. You have to keep your eye on that start point. So when you go to connect these, okay, and then you can get some action on the negative side, just to show some of those negative points. And that would be slide over 3 halves, plot at the middle level, slide over 3 halves all the way at the top, slide over 3 halves, come down again, slide over 3 halves all the way down, slide over 3 halves right there just to get a little bit of graph on the negative side. Okay, so that's plenty of the graph. The domain, what they ask for all these problems is negative infinity to infinity. The range, you can see by your uppermost and lowermost levels, which were established using the amp. So we go as high as low as -7 and as high as, well, this is the x-axis right here. So if this is the x-axis, you're up at 3. Okay, so it goes as low as -7 where we plotted that start point, but as high as 3. Oops, got it backwards. As low as -7 and as high as 3. That's for the range. Okay, so if you're doing it in MyLab Math, you would choose the cosine tool. You would also tell it what point is on the graph. You have to give it a point. Click a point on the graph. And our start point just happened to be 0, -7. That's the point that will be easiest for you to use without causing yourself more work. Then tell it what the amp is for this particular graph. Tell it what the period is for this particular graph. And the period for this one was ended up being 6. And then when it comes to vertical shift, tell it that there is a vertical shift. That'll be this last number all the way at the end without any variable next to it. Vertical shift of -2. So you would feed that in there. There's no, let me see. what else is there? Yeah, reflection. I didn't say that yet. So reflect, check that off. You are reflecting. It did flip over. And we did that right here with this reversed pattern, DMUM. Went down, middle, up, middle. Because typically this point, this start point would have been up here. You would have had a maxed out point at the beginning. And instead we had the most minimum point to graph it, to start it off with. So yes, you're going to check reflection over the x-axis. So all those things in this problem. Okay, number 14. Okay, so now you come to example 14, and what you have in this particular graph is that it's just not in the order that we've had all the rest of the problems in. You should always be looking, and you can leave it like this if you can be confident that you're going to pay attention throughout the problem, but that's really your A value, and that's really your vertical shift. So just to cut down on possible mistakes, you may want to rewrite it in the form that we have typically treated all the problems from. The A value first, then the trig function, then you have the B value as part of the X expression, and then the number that has no variable multiplied by it, that's your vertical shift. This is your B value. So you may want to write it in the standard form for a trig function. Okay, so the amp here would be absolute value of this -3. We will be reflecting. We're going to reflect over the x-axis. I've chosen a lot of those because it is easy to forget when you're doing getting caught up in the problem. So amp is 3. Period here is 2 pi divided by whatever the B value is, and that B value is 2. It's 2. Sometimes it's a pi type number, so sometimes you're dividing by a pi type value. But here we just end up with 1 pi for our period. Our jump is the period divided by 4. And the start point is just whatever makes this, causes a 0 to occur in this argument, which would be 0 for x. And then to get y, you would just imagine what value would I get if I plugged in, and you can feed it in just like that into your calculator or like this. That's up to you. What would I get if I fed this into my calculator? Putting a 0 in for x, so you'd be feeding 2 minus 3 sine of 0, purposely causing an argument of 0 to occur. It's the simplest way to go when you're figuring out that start point. So sine of 0 is 0. 0 times -3 is still 0. So 2 take away 0. That's what you would have gotten if you pressed it into your calculator. And again, you could just kind of see it yourself. So 2 minus 3 times sine of 0. And there you go, 2. So you can get your calculator to do this portion for you. Okay, then, so we have that start point of 0, 0, and then our pattern. We've got to look at the pattern for getting us started here. So typically the pattern for sine is UMDM. That's what it is to begin with. The old pattern. And the new pattern, because you're reflecting, will be down, middle, up, middle. So you're switching this and this. Pay attention to that as you go to do the problem. DMUM. Just like we used in, oh no, wait, I think I grabbed the wrong pattern. I did. Okay, let me correct. pattern for sine, we're doing sine, is MUMD. That's the old pattern. I almost messed up there. Okay, so this would be old. Good thing I didn't graph using that. And then when you switch the ups and the downs, it would be middle can't be switched. So you'd be switching this to a D and this to an up. That will be your new pattern. So it's MDMU because you are switching the MUMD pattern that is typically used for sine. Okay, so we have, as our very first letter, we have an M, and that M reflects on the start point. It tells us that the start point is at the middle level. So we're going to go 0, 2 right there. Going to put that level in place. We know that the start point is at the middle level because it's the first letter of the pattern. Okay, then if we want the other levels, the one that's above the middle and the one that's below the middle, we just look at the amp. So we go 1, 2, 3, amp up 3 units. That is your upper level. And then amp down 3 units. 1, 2, 3. And this will be your downward level. Okay, this is our start point. Now we're going to carry out the rest of the pattern after putting some values on the x-axis. So it turns out that our jump was pi over 4, so we can label each grid mark 1/4 pi. Oops, putting that a little bit too high, so this will be pi over 4. 2/4 pi, this will be 3/4 pi. So 1/4 pi, 3/4 pi. So this is 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi. This will be 5/4 pi. To get some numbers on there, and then over here you'll have your negatives. Negative pi over 4, 2/4, 3/4. Kind of hard to write all that in. It's 4/4, 5/4. All right, so now we can start plotting the points. So now we're supposed to go to the downward level. So we're going to go over 1/4 all the way down to the bottom. Over 1/4, got to make our way back up. So over 1/4, this says go to the middle level now. But you know that you have to start climbing up even if you don't look at the pattern. So that's going to be there. Over 1/4 all the way to the top. Over 1/4, start to come down. Over 1/4, down, back down to the middle. Over 1/4 all the way down. And then begin connecting these points. Okay, so you can see that you're hitting this upper level at its highest or maximum point. You're hitting this downward level at its most minimum point, and you're passing through the middle level in between your travels from upper to lowest level. And we want to get some points over here on the left. Let's see, you were at the lowest level, then the middle, you're on your way up, getting all the way up after sliding over pi over 4. Slide over pi over 4 again, start to come down. Slide over pi over 4 all the way down. Slide over pi over 4, back on your way up. Slide over pi over 4 all the way up. Slide over pi over 4, start to come back down. And I bet that's plenty. Okay, domain is negative infinity to infinity. The range for this particular problem. Okay, well this goes as high as, let's see, this is 3, oh no wait, that's 2. This is the x-axis, so this is 1, 2, 3, 4, 5. So we max out at 5, and then we go as low as negative 1 right here. Okay. And I think you have the idea of what you're supposed to feed into my lab math at this point. That's 14. Last graph, most complicated, I guess, would be this one. Okay, you don't have any kind of a vertical shift. There's nothing added or subtracted at the end, nor have they switched it around on you. So this is actually your A value. This is your B value. And you're just going to start doing all your calculations. Amp is absolute value of whatever they give you for the A value. So just 4/3. Your period, well, that's a calculation. It's 2 pi divided by whatever the B value is, which in this case is, now let's see, they've given you a negative value inside your argument. So you have to understand that this is an odd function. Anytime you have an odd function, you can't just erase that negative. You can only do that for even functions like cosine and secant. So this actually becomes part of the A value, so that you're talking negative 4/3. But I mean, with the amp, it doesn't change anything. Even if you were to put a negative in there, it's still 4/3. However, once you see that this is a negative A value, that negative A value means you have an A value less than 0, and you are going to reflect. So you have to switch the pattern. You have to be very careful, and that's why I've chosen so many problems for you where you're flipping the pattern by switching up to down and down to up. So once you bring this negative out here, then it's just sine of this regular or positive 2/3 pi times x. And so you have the right to just plug in 2/3 pi. You have to know how to simplify a complex fraction here by taking this 2 pi over 3, floating it to the top, and flipping it over. So 3 pi over 2. Instead of 2 pi over 3, so instead of 2 pi over 3, it's 3 over 2 pi. Okay, so this is all now at the top. I've taken the 2 pi over 3 and flipped it over, and there it is right there. This 2 pi cancels with this 2 pi, and you're left with just 3. You have 2 pi in the numerator, 2 pi in the denominator here after this was flipped over, and you're left with a period of just 3. Your jump ends up being whatever the period is, just a formula, divided up into 4 parts so that you can use it for a 4-point plotting pattern. So that's 3, the period, divided by 4. So we're going to be labeling each grid mark 3/4. We're going to jump over 3/4 between grid marks. Okay, so let's plot also our start point. What you would plug right in here to cause a 0 to occur in this argument would be, and you can be looking at this one, that's going to be the more simplified one once you've taken that negative out front. So 0 will do it. If you put a 0 right in there for x, it'll 0 out that whole thing. You just want to figure out what's the y partner equal to. If you have a negative 4/3 out here and you're plugging in a 0. Well, 0 times this is just going to be 0. I mean, I'll write it out, but that's exactly what I'm doing. I'm plugging in a 0, which just results in you having a 0 for your argument. So that's really what you're putting in the calculator. Your calculator will give you a 0 for this, because sine of 0 is 0. 0 times negative 4/3 is 0. But you go ahead and plug it in if you'd like. Or do it in your head if you can do it in your head. So we have that start point and our pattern. Pay attention to our pattern because our pattern does have a negative there. So the old pattern is mum-d for sine. And then when we reverse the ups and the downs, this becomes down and this becomes up while the middles stay the same. We have md mu. So md MU is the pattern that we are going to be using. Okay, so let's go ahead and use that pattern with the start point. Remember, whatever the first letter is, that's where this start point is. So we know what level that we're on. Okay, so here's 0, 0. We're at the middle level there. And then the amp separates the upper level and the lower level from the middle. So our amp turned out to be 4/3. So this will be 1 and this will be 1 1/3 because this is going to be 2. So 1 1/3 is about right there. About 4/3. 1 1/3 is the same thing as 4/3. Let's try to make it a little bit straighter. Not much. Okay, so this is going to be our upper level. And then if your middle level is right here, we're going to go down 1 1/3. So this will be 1. This is -2. So -1 1/3 will be about right there. Okay. So we have our lowest level at -4/3 or -1 1/3. And we have our highest level at +4/3 or 1 1/3. Okay, so finishing this graph. Okay, we have the start point at 0, 0. We're going to next go to the downward level and we're going to use spacing of 3/4. So this will be 3/4. This will be 6/4. This will be 9/4. You're leaving the denominator the same. We had one problem like this already, but jumping in increments of 3. So that you're always jumping an additional 3/4. 12/4 is 3/4 added onto that. This is 3/4 added onto that. So just change the numerator while keeping the denominator the same. This will be -3/4. This will be -6/4, and so forth and so on. 9/4, 12/4, 15/4. Okay, so now we're going to go to the downward level. Slide over 3/4, downward level. Slide over 3/4, back up to the middle. Slide over 3/4 all the way up. Slide over 3/4, start to come back down. Slide over 3/4 all the way down. So this will be down, up, middle. There we go. Plotting all the points and connecting them. Now if you want to get some points over here, here you were on your way back up, so slide over all the way up, slide over, start to come down, slide over all the way down, slide over, back up, slide over all the way up, and you have some portions of the graph on the negative side. Okay, domain here would be the usual. -infinity to infinity. The range would be, let's see, this goes as high as 4/3, 1 1/3. That's the max. 1 1/3 is the same thing as 4/3, and it goes as low as -4/3. So that's your range. And then as far as commands for MyLab Math, to just choose the right tool. I think you've seen this enough. Choose the sine tool. It'll ask you to click on a point before it'll open up the other questions. So you can click on any point that's on the graph, which we know ours goes through 0, 0 because that's the start point. And then you can begin to tell it the other information, which it'll ask you what the amp is. The amp in this case turned out to be 4/3. It'll also ask you what the period is, and the period turned out to be 3. That's up there. The amp's up here. That's why you should lay out all this stuff, of course, before you start doing the graph. And then there's no vertical shift or horizontal shift. However, there was a negative that got brought out as part of the coefficient, and therefore a reflection is indicated. That reflection happened by way of us switching the U's and the D's in this pattern. Okay, so you will check off that there is a reflection about the x-axis. Okay, lots and lots of you putting in graphs into the calculator. I mean, you doing graphs by hand. I did want to show you a couple of graphs. Just when you go to put it in, you can put any of these in the calculator. You don't have to know anything. You don't have to know much because you're getting the calculator to do it. So just a couple of things that you do have to be familiar with that will help you is that, remember, if you're going to put things in the calculator, you have to be willing to mess around with the pre-made windows on the zoom key and manually adjusting things on the window. As far as answering questions, your handmade graphs are going to be clearer, but you can use the calculator graphs. On the test, some will be by hand, some I will allow you to do by calculator. So if you do one by calculator, you just go do what you always do for the graphs. You're going to go y is equal to, let's say you're feeding this one in right here, and we already know what the graph looks like, and this can just serve as an answer key. Your calculator can just serve as an answer key. So you can just type in -4 sine of x, with the key with the x in it, press enter, and then a trig or standard window is nice. Okay, for purposes of what exact points are, it's a little harder to read off the calculator, but you can get information such as what are the x-intercepts. You can also get that from your calculator graphs. If it was a multiple choice question on a test, then you could use a calculator. That would be a good problem to use a calculator on, but notice this has the same shape. It goes up right on the left side of the y-axis, just like ours goes up. It goes through 0, 0. It has a minimum point. Well, on our graph, we know that that minimum point was pi over 2, -4. Whereas here, you'd have to go into your window to get, or your table to get those values. Okay, let's do another one by calculator. But just basically feed in what you see there. You could go do this one. This would just be y is equal to 4 times cosine of x. Close that, plus 1, press enter. And you can use these pre-made windows, standard or trig. You get like a nice graph there. Now, if you see that there's something that you want to answer a question about, like what is the maximum value, you can always adjust the window manually. We used these pre-made windows under the zoom key. So if you press that and you don't like that the top is cut off and you want to use that for purposes of the range, you could say 1, 2, 3. I need that y max to go higher than 3. So you can press window, and then you'll see that y max goes to 4, but how about if we make it go to 6 so we can see where it hits. And then you can tell what the range is by way of your graph. You can just count 1, 2, 3, 4, 5 is the max, and then you can tell what the min is also, -1, -2, -3. And notice that that was the same range that we got by doing ours by hand. Okay, so when you do it by hand, you're actually learning the graph theory of how to get this done. and the things that play into the pattern for each of these graphs. When you do it by calculator, your calculator is doing it all for you. Okay, last problem. Very last problem is that you should be able to look at a diagram of a graph and understand how to retrieve the period from the graph and the amp from the graph and basically what the shape is. So remember, the sine graphs go through 0, 0 if they're in this form where they haven't been shifted. And the graphs that go through 0, 1 are the cosine graphs. So because this goes through 0 and then some number, rather than going through 0, 0, I know it's the cosine graph. So this is going to be cosine graph, and that's because this one goes through 0, 0, so I didn't pick that. I want to know what that amp is. They're using this omega symbol, but that's really the same thing as B. This is the same thing as your A value. Okay, so do you see that this is 3 units tall this way? The wave that goes up like this, it has a height of 3, and so does this one. See, this is -1, -2, -3. So this also has a height of 3. So that's the amp, whether you go upward or downward. And then this thing has to do with the period. The B value plays into the period, and the period can be seen on the graph. Okay, the period is the distance that it takes you to plot 4 points and return to the same Y value. So why don't you take these two maximum points that are both at the same Y value right here and ask yourself, what is this distance for you to be at a Y value and then return to that same Y value as you plot successive points? So let's see, what is the distance from here to here? All you can do is you can just count the grid marks. Now there's no pi type numbers down here, which that's possible. We graphed a couple of graphs like that. So the distance from here to here, it could be a pi type number if there were pi units here, but there aren't any, so this is just an integer. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I believe that's right where we're at. Because this would be 10, 11, 12, 13, 14. So yeah, that's at 9. Okay, so the distance from here to here is your period. But remember something, in every graph that we've done, period was equal to 2 pi divided by the B value. And if I just had that B value, I could finish this problem. So my period I got from the graph. It is 9. And then I'm going to copy the rest of the formula that goes with period. And if you want to solve for B, well, that's a form of cross multiplication that can be done in 2 steps, but it could also be done in 1 step. When you're solving for anything, it can't be in the denominator. You need to get that B up in the numerator level. You can do that just by switching these two. So put the B where the 9 was, up there at the top. So this takes that place, and 9 goes in place of the B. So that's the B value that I need to finish this problem. B is the same thing as, they just used an omega there. Okay, and that is the equation for this particular graph. Okay, that completes a 2-hour presentation, but just slide this to wherever you need to slide it. So you can look at whatever you need to do. That concludes section 6.4.